external sources also, which leads to the contribution of heat in the conditioned space. The cooling load for these components must also be considered while calculating the cooling load for entire building. For calculating the total cooling load, the first reason for internal cooling load can be due to people present in the conditioned space. The formula to calculate cooling load due to people is given as the sensible cooling load equals to the cooling load per people times the number of people. So in this equation, QS denotes the sensible heat gain measured in BTU per hour. The next term shows the sensible heat gain per person. And finally, N is the number of people. The people inside the conditioned space also gives rise to latent heating. And this can be calculated from this simple formula where QL is the latent heat gain and the next term is the latent heat gain per person, and in the same way N is number of people. So these are the two formula used to calculate the cooling load due to people. This is a simple problem which will help you to understand how to calculate the cooling load due to people. So the question says, what is the heat gain from people at night in a movie theater of area 9000 square feet at 75-degree dry bulb temperature? Because the formula to calculate sensible and latent cooling load due to people have already been discussed, so we'll make use of these two formula. But we need to get the values of these two terms from the tables. First we'll find number of people. Again we use the same chart of minimum ventilation rates in breathing zone. Here we are talking about movie theater. So we select the row corresponding to movie theater and the column for occupant density. We get the value as 35. So for 1000 square feet area, occupant density is 35. So number of people is 35. For 1000 square feet, number of people is 35. So we calculate for 1 square feet number of people, which is something 35 by 1000. And for 9000 square feet, because the theater we are calculating for has the area of 9000 square feet, so we use the value of 9000 square feet. Number of people is calculated as 315. So now we have the value of number of people as 315. Next, we find the sensible cooling load per person. Again, we select the row for theater and the column for sensible heat. We get the value as 245. Now we have sensible heat gain per person, which is 245, and number of people, which is 315. On multiplying these two values, the value of sensible cooling load due to people is found as 77,175 BTU per hour. Now we find the latent cooling load. We select the column of latent heat. The value is found as 105. Now we substitute the value in the equation as 105 times 315. The final value of latent heat is found as 32,025 BTU per hour. When adding these two values, the total value of cooling load for the people is calculated as 109,200 BTU per hour. Heat can also be gained into the system due to the lighting used in the conditioned space. So the cooling load due to lighting also has to be considered while calculating the total cooling load. The formula to calculate cooling load for lighting is given as Q equals to 3.4 times W times BF times CLF. Over here, Q is the cooling load from lighting, W is the lighting capacity. The value of this lighting capacity has to be substituted in watts and not in imperial units. The term 3.4 used in the equation is only because we are not substituting the value of power in imperial units but in SI system. By multiplying the value of watts times 3.4, the total value gets converted to imperial system. The BF used in the equation is the ballast factor and CLF is the cooling load factor for lighting. Now ballast factor is a new term. We'll understand a little about this term. It accounts for heat losses in the ballast in fluorescent lamps. The ballast is a component used in lighting which controls the current and thereby involving in heat load calculation and cooling load calculation. The value of this ballast factor is taken as 1.25 for fluorescent light and 1 for incandescent lighting. This is a very simple value and should be memorized for easier calculations. And finally, the internal cooling load for equipment and appliances used in the conditioned space must also be calculated. We again use the same formula to calculate the cooling load and all the terms are the same. Mostly, these values are found from charts and tables provided by ASHRAE. Also, many a times the value of cooling load due to equipment and appliances is directly given by client or architect, which can be obtained while doing building survey. We've already summarized the external cooling load factors. Now it's time to summarize the internal cooling load. From people, the cooling load calculated are from the formula given as this, and for lighting and equipment and appliances load, the formula used is a different one. So as a whole, the cooling load due to external and internal factors are found from these given formulas. Congratulations.